Hi, my name is Ji Wan Chung, and I'm back here to continue with the final part of my project for the text analytics class. So this is my new table of contents. So I will first start with the motivation and the ideas. Then I will continue with the discussion of the value and some of the difficulties I encountered throughout this project. Then also I will show how I carried out the methodology for for the actual like a practical development, and then then based on what I did, I will show the results and the validation, and I will wrap up with the conclusion and the discussion. So the motivation and ideas. So my motivation has always been pretty much the same. So basically, it is the recommendation system that has always interested me since I actually kind of started my third term in my PhD, and you know this is like a great opportunity for me to actually see what kind of data is involved in recommendation system and what kinds of like algorithms are actually involved in it. So it was a motivation for me to actually kind of like practice and test out with the new data and observe how big like a data analytics can actually be a great contribution to the customer relationship management. And so basically for me it was an opportunity to process, analyze, and restructure a large data set, which commonly is utilized to extract some new data information and give solutions to some industrial operations. So it's like a valuable step towards gaining knowledge and experience to actually develop a novel recommendation system in the future, which I'm looking forward to do so. So I will start with the methodology. So basically, the methodology involves various like a coding techniques and coding like manipulations to you know do some text mining and structuring techniques. And throughout the process I used the two databases. The first one is the database of the information of the videos, such as the number of likes, the number of subscribers, the comments and descriptions of the videos, all those things of the YouTubers. And this was provided by the consulting firm Uconnect. And the second database is the database that my team members and I created by ourselves via web crawling, and we actually got some data of some random YouTubers who do advertising in their videos. And so we took these two databases, and for each databases we clustered each YouTuber's unique video channel IDs in order to organize the database in more of a organized and compact manner. And for each description and the title data in the databases were pre-processed with the regular expression and Korean morphological analysis to get rid of all the like noisy text in order to only focus on some clean words to get the value of the cosine similarity between those. And just for the sub practice, I actually also took and got the top five most frequently used text that for each YouTuber in the dataset. So this is the image that I just explained to you previously. So between the titles and descriptions between the two databases, I calculated the cosine similarity. I first implemented the Doctubek algorithm and by using the two vectors, I calculated the cosine similarity between those in order to see which YouTubers of the two databases are closely related to each other. So just so you have a better idea of what I did, I actually wanted to show you some of the the coding process that I implemented. So basically this first code, as you can see, is used for the text cleansing, which is used to remove all those like unnecessary words such as images, the URL addresses, and some like complex symbols such as exclamation marks, pound keys, and start keys. And once I did that, I also for each word, sorry, for each for the corpus in the description of titles, I actually extracted the nouns, only the nouns. So because those would be the main keys that actually that actually describe what the videos of the each YouTubers do, what exactly the YouTubers do. So yeah, I applied the functions, all those functions, text pre-processing functions to the to the data, the descriptions and titles. And yeah, this is the code for the Korean morphological analysis, and this is the Komoran um, like a package that is commonly used in here in Korea. So yeah, it's basically basically substituted all those like unnecessary text with the regular text, and I try to identify the nouns by making a list of all those like recognizable words that actually help people to recognize the nouns. And finally, after all those like sorts of multiple lines of codes, I actually implemented the Dr. modeling in doing this code, and this is the library that I utilized with the GenSim library. And once I got that, make sure I ensure that the Dr. is implemented for every single row for the titles and the descriptions. I took that and took it and carried out until here, and also created like a cosine similarity for the top um, the top most frequent videos, or the most popular videos that exist in the databases. So the value and the difficulty of the project. So there was some difficulties within the project, and one of them was that there were several YouTubers channel IDs that were duplicated. So they were like repetitive same IDs, and this can actually provide some unnecessary algorithmic results when it comes to recommendation, and it can also delay some of the data processing and the how you say the data learning time. And there were also several, as I mentioned previously, several like informal style of writing. You know how the YouTubers, they, especially people in Korea, they actually don't really try to like write everything formally. They actually shorten like many words, and they don't even like follow the right style, or they don't ensure that actually they finish in the right way. So there were a lot of those like mistyped text, and there are also numerous uses of images, URL addresses, and other noisy text, which can and severely disrupt the text similarity measurement. And content similarity actually turned out not to provide the best outcome for the text similarity, and that of course means option to implement and necessity to implement other algorithms, which I will show later on. And these are the results from the validation. So basically, as you can see, each column shows the channel ID and the video ID of the. So for this whole block of the data sheet are from the database 2, which we got from the web crawling. So we actually chose we selected one unique type of YouTuber recognized by this ID, and then we actually try to compare him with or her with other like various YouTubers that exist within the Uconnect database, within database 1. So we wanted to see um, which to which of all these like multiple. This is just the first 5, by the way. Which of these would be closely related to the YouTuber at the database 2, based on the the descriptions and also the text and the title text similarity between the two. And ultimately the result turned out to be like slightly lower than 50%, which is not obviously not very far away, but yet not very close. And the average constant similarity between the unique YouTuber ID and all the other YouTuber IDs from the other database uh, turned out to have relatively like a high distance. So I kind of concluded that maybe Doctobeg is not the best option. And so yes, so it didn't actually provide the best outcome. The values were very close to zero. So um, starting from now on, for the time that's left for the project, I will study hard and try to implement the SIMRank and the TF-IDF, which are other types of like a common algorithms for the text um, relationships and similarity. So, but still, this project still remains like a valuable opportunity for me to test out a new simple yet commonly used algorithm to calculate the text similarity and see which YouTubers are related to each other. So, um, yeah. So it's been a pleasure to actually have a chance to do this project, and thank you very much for listening. And these are the references that you may want to check out. And thank you again for listening, and have a nice day. Thank you.